probably keep this a little bit short since there's not a ton of people here today. But I think it's kind of interesting. Some of those questions you guys or topics you present, I'll try to have more thrown together for that next week. For today, I want to go over, we've talked about the hot hand before a little bit. So this was the idea that people will sometimes fall victim to, which is that if I'm flipping a coin, right, and it comes up heads 3 times in a row, the hot hand fallacy is the idea that I believe that, well, this coin, it's come up 3 times in a row, it's going to come up heads again, right? The gambler's fallacy is that you think that it's going to even out. So that would be that if you see 3 heads in a row, you think, well, it can't come up heads 4th time in a row, right? But the underlying probability is always the same. So first thing we'll kind of think about is just whether or not a hot hand exists in basketball shooting, right? So a lot of people, if you watch basketball or you listen to announcers, a lot of the times they'll say something like, oh, this player's hot, or, he's on a hot streak. But if we have, flipping a coin, you can see a streak of like 4 or 5 heads in a row. It doesn't mean that the probability the coin comes up heads on the next flip is anything different than 0.5 still. And if you want to think about it, it's almost like there is some underlying probability, even like, let's say you have a really good free throw shooter, right? The probability they make that free throw is 0.9, right? Well, just because you see them make, I don't know, 15 in a row, the probability they make that 16th one is still 0.9, right? So you can see these long streaks, but it's not necessarily indicative that the probability has changed at all, right? The probability is still whatever their natural ability is. Just like when flipping a coin, the underlying probability is always 0.5, okay? So what's one way we could test for this, right? Well, the most naive approach would be, okay, let's say, and I'll use free throws as an example, just because you can kind of think about when you're shooting a shot during the game, there's a lot of things changing, right? Free throws, you're the same shot, right? I mean, you're from the same location. Maybe the circumstances of the game are a little bit different, but we're taking the exact same shot. And so we'll kind of say free throw made, right, is our 1-0 variable. That's what we're interested in, right? So remember when we had coefficients for 1-0 dependent variables, it was always changes in the probability we went from the 0 to the 1 group. Or here, the probability we made it instead of missed the shot. So if I think, whoops, I'll use betas here. If I think that a hot hand exists, right? So maybe I have this idea of, so there's this literature. This is not my expertise, so hopefully I'm going to get this right. I don't think any of you maybe expertise in this either, so you can't call me out. But I've dove a little bit into the research done. There's something like neuroplasticity. So when you do a certain physical movement, so they had this test where people were had a cursor on a mouse and they couldn't see the target. So they had something set up, there was a target on the screen and they had to move the mouse. And whenever the mouse went over the bullseye, it gave them a positive feedback response, right? Like it said, you hit it. And even not being able to see it over time, they got more and more accurate at being able to make that cursor go over the bullseye, even though they weren't able to see it. And this is the idea that the physical movement that led to a success, well, knowing it was a success, it built that kind of movement pattern in the brain so that they could replicate it, right? So there is some evidence that physical movements that lead to a success might make it more likely you can replicate those physical movements for a success down the road or on the next attempt, right? So I think there's some, they've done some stuff on dart throwing as well, right? So if previous success could influence my success on the next shot, then what I could do is say, if I go back 1 shot, so T-1 is just kind of saying if I could order all the free throws that somebody took, just go back 1 free throw. If they made that previous free throw, what's the expected change in the probability they make the next one, right? Or the current free throw. So if we think that if there is a hot hand, what should the sign of this coefficient be? Positive, right? If it's negative, that actually means, we've got, a cold hand. I don't know, right? It's not, there's nothing there. So that's the general kind of idea and setup. Let's see.
I had a bunch of papers pulled up, so I've got a couple of these. So this one I think is the one I'm going to start with. So I'm going to scroll down here. Kind of, I wrote this paper with, have you guys had Professor Nesson? Any of you? A couple nodded. Yeah, so him and I wrote this paper together, and go down here to the results. Actually, they might be all the way at the, yeah, okay, this is an older version. So let's say we want to go just to the basic ones. All right, so there's our summary statistics. So we had something like what? Oops. We had 2 million shots. So we had field goals and we had free throws. So we had like 2 million shots taken during the game or field goals, and we had about 500,000 free throws, right? So a lot of data, right? You can get play-by-play data for basketball, especially if any of you have like dove into R at all. There's some R packages you can scrape all the play-by-play data if you want. You can actually do it for college basketball too. And what we did was kind of, the natural progression you see in a lot of papers is we start out with this very naive regression, right? But, making a previous free throw, right? There might be a lot of others. I said it's like the same shot, but what's going to be true if we're looking across players? What's true about this underlying probability for some players? Yeah, Shaq shoots like 50% or whatever it was, free throw percentage. Some people shoot almost, 90, like 95%. So every player is going to have a different underlying probability. Also, these free throws being taken, they're a different game, right? What if it's a 20-point game versus a 1-point game in the last 30 seconds? There's going to be a lot more pressure on that second free throw I mentioned in the first. So we want to try to control for all these game factors, right? Things that might influence whether or not I make a free throw, right? I feel an increased amount of pressure. And also somehow control for a player's underlying probability, right? Excuse me, of making that. So we did like a similar thing for field goals, right? It's going to be really the exact same regression. It's just that you're looking at, did they make the previous field goal and did they make the current one? And then we start including things like, what was their field goal percentage on the season, right? Or what was their, up here, free throw percentage on the season, right? This somehow, this is going to control for what was the underlying probability that player made the free throw, right? That's going to deal with that issue, right? So we start to throw in these additional controls and we kind of show how they matter, right? So we start out with this very naive regression, right? This is the first one that I wrote out, right? I just have one dependent variable there and it looks like, oh, there might be a hot hand, right? And this is free throw or field goal. So this is free throw shooting, right? So it looks like, okay, there might be this hot hand, right? If a player previously made a free throw, it increases the probability they make the current free throw by 0.06, which is like a 6% increase. Pretty large, right? Now, I throw in some game controls, goes down a little bit. I throw in some player controls, and this wasn't even their underlying field goal or free throw percent yet. This was just things like age, years in the league. I forget all the different kind of player controls that we had. I think they're like height and weight. We then kind of threw in, okay, what are the circumstances surrounding this shot? What's the score differential? How much time is left? All these other game kind of controls, or shot specific controls for during the game. Notice it doesn't change a whole lot. We then include the free throw percentage for the season, right? And we call it leave out free throw percentage. There's some econometric issues where, well, we won't dive into it, but you can just think about this as it's the free throw percentage on the season. So once we include that, notice it cuts that estimate almost in half, right? The reason why we were seeing like these longer streaks is because if we weren't controlling for the player's underlying probability, these players that have higher probabilities of making it, we're going to see a lot of consecutive makes, right? But once we can control for that, what we're really saying is two players who have the exact same free throw percentage during the season, they're taking shots that have the exact same score differential, exact same time remaining, exact same, et cetera, exact same height, exact same weight, exact same age, exact same experience in the league. And then I think the game controls are like, they're taking on the exact, we had month, week controls. So like same time during the season, we had season controls. One of them made their previous free throw. What's the increase in the probability they make the current one? And it's still about a 2% increase. Right? So once we've controlled for all these factors, we're still seeing evidence that there is kind of this positive effect, or that there is maybe some hot hand when it comes to success in free throw shooting, right? And we do some other stuff here, which it's not overly important. I think so I'll mention it here because it is kind of interesting. So the reason why in this last column, we excluded the observations, notice we use like all the same number of shots, except for here, like our sample size fell to 300,000. We have this idea of like, if I take a free throw and then it was like the second free throw or whatever of my set, and then I don't get fouled again and for like another quarter, does I really, does that neuroplasticity still stick with me from that? It seems probably not as likely. And so when we only look at like the second and third free throw of a set, we see that the estimate actually goes up a little bit, right? That actually we were kind of understating this hot hand because it doesn't carry over as much from free throws that are taken a long distance apart. Right? And we'll kind of come back to this here in a second. It's kind of interesting. So, about a 2.5% increase is relatively large. Now, if I go down to my field goals, where is it at? Oops, I think it's right here. There we go. Basically did the exact same thing, but for shots taken during the game, like field goals, right? So same kind of idea. Started out with a very naive regression. What's really weird is I actually get a negative estimate or a negative coefficient here. So if you make your previous field goal, you're actually less likely to make the next one. Right? Well, let's think about what you might do. Let's say I'm in a game and I make a 3, right? We know that generally the further back you are from the basket, the lower the probability or the lower the shooting percentage is. So I make a 3. What would I be more likely to do the next time that I get the ball? Shoot another, or shoot it from a little bit further back, right? I'm getting some confidence. So maybe, free throws, we've locked in that distance, right? There's also no defenders. If I make a 3, what might the defenders do in the next play? Get a little bit closer, right? Make it a little bit less likely I make the next shot, which would explain why we're seeing this negative effect. Shooters might take shots from that are harder, and defenders might apply a little bit more defensive pressure. Okay? So we start to control for all these additional things. One of the things that we throw in there eventually is like defender distance. So there's this play that they did is crazy. It like also has like the XY coordinates on the court of where the shot was taken from and also where the nearest defender was. So you can calculate. I had to go back and do a little bit of trig stuff that I tried to forget. And then you could figure out how far away they are. So we include some of that in these shot controls. I think this is defender distance. And really notice, once I include those shot controls where I'm accounting for where the shot was taken and how close the defender was, it goes to 0. I can't say that there's any effect of making the previous field goal on the next one. Right? And when I control for the player's underlying shooting probability, it's basically different from 0 because we have 2 million observations. But I mean 0.002 would mean that it's a 0.2% decrease. So it does look like maybe there's an effect. But we also then controlled for like, well, what were the conditions of the previous shot, right? Like, did I previously take a 3? Like, what was the score of the game? And there, once again, we get this estimate basically of 0. So on its face, right, if we don't control for all these other things that players could be adjusting, it looks like there's like a cold hand effect. But once you can control for all those adjustments, those behavioral adjustments, we get down to there's absolutely no effect. And just to kind of prove that that's what's going on, scroll up here. And then, so we had this idea of, okay, maybe players are making adjustments. So you could do something like, what happened to the shot distance? So use that as my dependent variable. When a player, actually, sorry, this is field goals. When a player previously made a field goal, right? So this is gonna, this estimate would tell me if they made their previous shot
what's the impact on shot distance, right? How much did the shot distance of the next shot go up or down? If we think they're taking riskier shots or lower probability shots, we might think this is positive, right? If I make a shot, I might be more likely to take a shot further from the rim on the next one. So we used a bunch of different kind of behavioral adjustments for our, these are all different regressions. So here our dependent variable was shot distance, right? That's the one I just kind of wrote out for you. So if you make your previous field goal, the next shot you take tends to be about 1.5 feet further back from the rim, right? We also looked at kind of the difference in the shot location. So not just did you move further from the rim, but like you move kind of side to side, and we see there's an effect there. Well, if I start moving locations, depending, I mean, I guess for some people this might not be true, but at different areas of the court, I'm going to have to use different physical movements, right? If I'm using different physical movements, any effect of that hot hand we talked about, it's the neuroplasticity. It's repeating the exact same movement. So even though you're shooting from a different angle, that neuroplasticity, right? That muscle memory, it's not going to carry over. So we see they're taking shots from further away, from different angles or locations on the court. They're also, we see that, you know, this one's kind of interesting. If I previously make the field goal, the time until the next time I take a shot goes down by about 19 seconds, right? Which is essentially like almost like one possession, right? I'm more than one possession, you know, it's going to decrease before I take the next shot. You also see they're more likely to take the next shot on the following possession. Right? So this is the idea that these players are bolstering confidence. They're more likely to take a shot in the next possession. They're going to, you know, be moving back a little bit further from the rim, and they're kind of changing their location. They're not even trying to replicate the exact same shot they took. Now it's interesting here is the defensive adjustments. So I think we did defender distance. Why is that not? I don't know why that's not in this table, but basically if you use defender distance here, we found a negative coefficient, which would mean that if you make the previous shot, the distance between the nearest defender actually goes down, right? They get a little bit closer. And then you also see teams are responding to when a player makes a shot. They're more likely to call a timeout or substitute a player in potentially for like a defensive adjustment, right? So that's kind of the evidence that supports like why in table 5, we find this negative effect if we don't control for those things. If we start to control for things like shot distance, defender distance, then we actually see it go down to 0. Any questions or interests?
Well, I guess I'm confused. If that were the case, how come every single team isn't shooting 50% like every single player?
So it's not that it has to be 50%. Because remember, what we're controlling for here is what their underlying probability is as well. So what this is really saying is when I take a shot, let's say my field goal percentage is 60%. What this is saying is that making a shot doesn't change that probability. It's still 60%. It's not saying it's 50, right? It's whatever that player's, like once we get here and control for the player's field goal, it's whatever that player's underlying probability, it doesn't change across shots. Which, look, I get that this like goes against like the way we think about things. But we recognize patterns. So one thing you don't do in your mind is you don't control for all these other factors. Like you see shots being made and like 5 shots in a row will stick out to you. The conditions surrounding those shots, you don't recognize that maybe those were exactly the same with those sides or that they changed at all. Right? So once you can control for all those factors, that those streaks actually go away. And what you're really probably focusing on are players who do have higher probabilities of making shots. Just like if I flip a coin, if it was 50%, I might get 4 or 5 in a row. I mean, if I've got a probability of 90%, I might see 15 or 16 in a row, right? Or it's at least possible to see those streaks.
Yeah, I was just gonna say, like, so does that, are people on average like moving back or, you know, taking different shots even like after layups and dunks or?
So, yeah, so one of the things that's in these shot controls as well, it's a really good question. We actually control for the type of shot. So it comes in as, they specify shots as, let's see if I can remember. Jumper, layup, dunk, 3-point shot, and there's, they have a difference between We have jump shot in there as opposed to a shot where, I don't know, so there's all these different kind of types of shots that we control for as well. But you're right, it might be more interesting to look at things that are further away from the rim, right? Because, but once again, there, controlling for that type of shot is important because you know the probability of a dunk is like 90, I don't know, 99%. Sometimes people mess up, but like, whereas a 3-point shot, we see averages far below 50% for a lot of players. Any other questions on this before we keep moving? Okay, so we do some other stuff. I don't know if there's anything I want to mention here. No, I won't, because I think I want to focus a little bit more on this. So we then had this idea. This is kind of cool. We like those results. Other people kind of liked them. So we said, what's like a, so we found this effect for free throws, but not for shots taken during the game, right? But if it really is that there's some type of muscle memory, this neuroplasticity, it shouldn't matter if I can take the exact same shot. Right? So we started thinking, what's like another scenario where players are taking the exact same shot over and over again? Yeah.
3-point contest.
Yeah. So we're like, is there data on the 3-point contest? There's not, but we can watch YouTube videos and then record whether or not they made the shot. So we sat there, watched a bunch of YouTube videos, and recorded. I forget how far back we went, and this might tell me here. I didn't put the year up here. Well, however far, 86 through the 2019 NBA 3-point contest, right? So we got all this data. It's about 9,000 shots, right? Now, one thing that's nice is what is probably also true about players in the 3-point contest when it comes to the underlying probability they make a shot.
Better 3-point shooting.
They're all there because they're good, right? So the underlying probability, while we'll still control for it, right, should be more similar, right? So we go down here. Let's look at kind of our first kind of naive kind of regressions, right? So it's the exact same thing that I had written out before. We're just going to say, did you make your current 3-point shot? And how is that impacted by if you made the previous one, right? So anytime we're looking for this hot hand, we're always looking at what we call the lagged variable, right? So did I make the current shot? How is that impacted by the lagged shot or the shot previously taken right before that? Okay. So let's go here. And we start to kind of include, well, what was their 3-point percentage like shooting during the season? We also can control for different things surrounding the shot. So we did things like what number or what shot location was it? So in the 3-point contest, if you're not familiar, they move from like shooting the side to moving from like shooting kind of a 45-degree angle, straight on, 45-degree angle, other side of the court. Okay. So you got 5 locations, and some players, right, where all players might be more likely to make shots straight on as opposed to from the side. So we wanted to control for that, so we did that. We controlled for things like, I think, player age and all those player characteristics as well. I then said, okay, well, what was the shot number? Was it the first shot taken from that location? Second number, we controlled for that. And then also, how long between the shots were you taking, right? Because what we noticed when we were watching some of these is that if a player starts to get up by a lot, where they think that they might be able to win the round, they might towards the end start taking a lot longer to take those shots to guarantee they make them. Well, that's kind of, I don't want to say it's cheating, but like, we don't want to pick that up, right? We want to just know what was the underlying probability made. So we're going to control for that as well. And what we find here is an effect that's even larger than for free throws, right? So if you make your previous 3-point shot in these contests, you're about what? 5.5% or 5.4% more likely to make your next shot, or the probability you make your next shot goes up by 0.045. Right? I'm saying this in terms of percentage. The technical interpretation of the coefficient would be if making the previous shot goes from 0 to 1, so you make it instead of miss it, the change in the probability of your dependent variable, making the current shot, goes up by 0.05. The way we kind of typically say that, 5% increase. Okay? So that's a pretty sizable effect. We then started thinking about, hey, we did try to control for like the shot number, but what this idea of repeated movements of the same, or you're doing the exact same movement, that's what's maybe going to be driving this neuroplasticity. What's maybe something that's going on here with this 3-point data that might actually be understating what the effect is? So if I'm in first location, right? I take the first shot. I can't use that data because there was no previous shot, right? I then take the next one. Well, if I made the first one, I might be a little bit more likely. So let's say I go through all 5. Let's say I make that 5th shot at the first location. I then have to move to the next location. What's going to be true about that next shot? Not exactly the same, right? In fact, the distance, right? If I'm moving in the NBA, technically, you have to look at, I think I have a draw. We have a drawing in here because it is kind of odd, right? The distance actually changes, right? You can use, once again, use some trigonometry and you see, oh, the distance actually changes between these locations. So not only am I from a different angle, it's not even the same. No, let's get rid of that. So it's not even from the same location. So maybe I only want to use shots if they were taken from the exact same location. So what that's going to do is it's going to basically drop every first shot of every location. So we go down. This is what I wanted. Yeah, here we go. So this is kind of cool. Let me see. Which one do I want to show you guys? I think we'll do this one because I think it'll be a little easier to understand. So what we then did is we said, we're going to run this same regression, but we're only going to use shots from specific locations, right? So here, we're only going to estimate what that hot hand effect was for shots taken from that first location. Right? So when we did that, right, we found no significant effect. So when I take that first shot from a location, it doesn't matter if I made the previous one because it was taken from a different spot. It was a different muscle movement. However, once I am looking at that second shot, now shots are being taken from the exact same location. That's where we see these positive effects, right? So actually we're kind of understating the effect when we are including all shots because for that first shot, it's from a different location as the previous one. There should be no carryover, but not as much carryover. In fact, here, we can't say that there is any carryover at any significant level, right? Let me think if there's anything else I wanted to say here. I think we'll say this. Let me see. Yeah, we'll do this in a second. Yeah.
So that might have, the specific shot location might have done it, but was there a different sort of control for where a player put their money rack at?
Yeah, so actually we had an indicator for whether or not it was a money ball, because in some years there's a money rack, but then the last shot also has an increased value. So yeah, we controlled for that and controlled for them if it was on money rack or a money ball. Yeah. But you're right, that could have also influenced it. We actually, no, just thinking about this the right way. Any other questions here? So this one might be a little bit harder to understand, but I think it's kind of interesting, so we'll kind of walk through it. So we did some, well, I'll show you. We did some, I guess, kind of fancier stuff. And we used a bunch of interaction terms. So we had not only so we basically did all these indicators for the previous 3 shots. So did I hit or make 3 of my previous shots? We then included an indicator for, did I hit my previous 2? And actually, sorry, I think the way that we wrote this was, did I miss the shot 3 back and then make the previous 2? We kind of kept going. Did I miss the previous, second and third shot, but make the previous 1? And kind of did all the different combinations for hits and misses, or makes and misses in the previous 3 shots. These coefficients should then tell me, okay, here's the effect on my current 3-point probability if I made 3 of the previous 3 points. Now I have to leave one group out here. And I believe, if we look at the table, I think we left out if you missed all 3. Yeah, right. So all of these interpretations are relative to missing my previous three shots. So notice if I miss two and then make my previous one, and I kind of excluded that first location because we were kind of concerned with that it's a carryover. There's a positive effect there, right? So it doesn't even matter that of the last three, I missed two of them. What matters is I made the shot immediately preceding the current shot, right? That success that would have led to kind of building in that neuroplasticity was immediately preceding the current attempt. You'll then kind of notice, like, even if I made the middle shot here, if I missed the previous one, I'm no more or less likely to make that next one. If I made one 3 shots ago, but I missed the previous 2, still no effect, right? If I made or missed the shot 3 times ago, but I hit these 2, like the previous 2, well, now that effect goes from 0.05 to almost 0.08, right? So if I can make 2 3-point shots in a row, it's even more likely I can make the next one. And then this one, once again, doesn't matter that I had a miss in the middle. If I make the previous one, I'm still getting a positive effect. Here, if I make 2 in a row, but then I miss the one preceding, no effect, right? So this is really highlighting the fact that the shot that matters the most is the one immediately preceding, right? But if I can get longer streaks, notice like when I make 3 in a row or I make 2 in a row, I'm getting estimates that are a little bit higher than just making 1. So it's not just that the previous success matters, it's that longer streaks of previous success might matter, right? And we do a little more complicated than the other one, but just to mention, you see the same thing happening with free throws as well. If you make more free throws in a row, it's even more likely you kind of make that next one. But the one that really matters is that shot immediately preceding the current shot. Any questions on this? Yeah.
How would you guess like the new like 2 4-point shots or whatever that are like 3 or 4 feet deeper, like
Oh, the 3-point contest?
Yeah.
Yeah, there was like they call them like the Mountain Dew balls or something like
Yeah.
that. Where so we specifically stopped at 2019 for that reason. Because and we did some, I remember we did look into it a little bit, and basically it just causes even more of a disruption for that first shot, because I remember right, they're taken before the shot that's straight on.
Mm-hmm.
And so you just see that there's even less, like there's absolutely zero carryover, because now you're going from location to location to location change. But I don't think we looked at whether or not it would influence not just the first shot, but like the second or the third. That would actually be interesting, because you're getting this real huge disruption in what that muscle process would be, right? To make these four, like for those of you that don't know something, they put this like one ball like from almost half court. I mean, that's not half court, but it's really far back, and then they try to make it. So it's like, it just causes more of a disruption in repeating that exact same movement, right? So one thing that we need when we're thinking about things like the hot hand or the gambler's fallacy, this is why gambling's a good thing, right? Or gambling's a good thing. Gambling's a good example, right? So if we look at the starting lines, they're 50-50 bets, right? So we like that because we know the underlying probability is not changing. We know that's the exact same. When we look at free throws, it's the exact same shot, right? That's what we don't like when the things change, because we can control for those things, right? But we need to be comparing apples to apples, right? We need to be controlling for things that are the exact same scenarios, right? And, things like a 3-point contest helps, free throws. But even in this, right? Moving that location, just a little change completely eliminates that effect, right? Which is something important to remember when you're thinking about like hot hand fallacies. Like any change at all could completely disrupt that movement pattern, which I guess would like lend to the fact that I don't know, if I'm thinking about even free throws, or if I'm thinking about, I don't know, bowling or something like that, I'm really kind of saying like superstitions are maybe superstitions that work, because you want to repeat the exact same movement patterns, right? And if there's something that you can do that allows you to repeat that exact same movement pattern, it might lead to more success, right? Any questions on this? Oh, what do I do? We got 15 minutes. I'll do. So I'll show you the opposite of this. So here I've got this paper. I gotta scroll down because they did some judge stuff, but that and loans. I want the ref or the umpires. Here we go. So let's go down to their results. No, that's summary statistics. Here we go. So that's the hot hand fallacy, right? We get this positive effects. Previous success leads to future previous success. But we know people can fall victim to the opposite, which is the gambler's fallacy, right? So this would be the idea. If I see 5 or 6 heads come up in a row, I think that next coin flip is more likely to come up tails, right? Because I think that it has to even out. But the underlying probability is exactly the same. So this paper looks at whether or not an umpire calls a strike, right? So this is just a 1-0. It then said, okay, did they call a strike on the previous kind of pitch? But what they do is they're only they also set controls for where was this pitch, right? So their idea is if I can get pitches that were in the exact same location, because they have this thing's called pitch FX, so it like tracks where the ball kind of comes in at. We can see that 2 balls in the same location, and what they actually say is not consecutive pitches, but just if I've got kind of my batters or my strike zone, when I see a shot here, when I see a pitch here, the next time I see a pitch in the exact same location, so if I called a previous strike when the pitch was here, am I more likely to call a strike when it's in that exact same location the next time? So it's not like consecutive pitches, but we're comparing pitches that were in the exact same location to the previous call. So if I think that they're falling victim to the gambler's fallacy, like maybe these pitches that are really close to the edge, that umpires are like, well, I'm not perfect. I know that was close. So I kind of like, if I called a strike on the previous one, I might want to balance it out. I might not be, so I might be less likely to call that a strike on the following one, right? Because I know they're close, right? If that's the case, they're falling victim to that gambler's fallacy. They're like, man, shots in this location, like all 3 of them strikes in a row, like that one's pretty close. Maybe I call it. And it's not like they have a lot of time to like think through this. So it makes very quick decisions. Maybe they fall victim to that gambler's fallacy, right? And that even though even though the pitch is in the exact same location as the previous one, they're more likely to call it a ball now. So if we looked at the results, when they looked at kind of the lagged, whether or not they called a strike on the previous pitch that was in that location. So here, I think this was, here was the lag strike. So the previous pitch. If they called the previous pitch in that location a strike, the probability they call that pitch in the exact same location a strike on the next time it's there actually goes down by about what? Probability goes down by 0.014. So about a 1.4% decrease in the probability they call it a strike the next time. And in fact, if they call it in that location, pitches in that location, if they called the previous 2 a strike, they're even less likely to call it a strike the next time it's in that location. And then, they kind of go through these different combinations. But really, it's kind of a similar story, which is it looks like umpires are kind of falling victim to this gambler's fallacy, right? If they think that pitch is a strike, if it's in the exact same location, they should be calling it a strike every single time, right? And like I said, a lot of this is done very quickly and almost subconsciously at their level. And, I always like sports data because you can answer really underlying basic questions with interesting data, but it can apply to a lot of other things. So here, when we see like decision-making falling victim to gambler's fallacy, well, it's just a ball or a strike, like who cares, right? It's not going to impact that many people's lives. But what they also do is they do the exact same thing. Let's not do loans. Loans, I mean, they matter, but not near as much. And I am not familiar enough with I don't dive into the whole into the law sector at all. But they did a really similar thing. But instead of using, did they call a strike on the previous, when it was in that previous location?
They did, I don't know. Did they send someone to jail? I guess I should have said, did they find them guilty, right? If in a very similar case, right, controlling for what type of case it was and, you know, the amount of evidence available, if they sent someone to jail the previous time, right, T-1, were they actually less likely to send the next person, right? Kind of this idea of like the umpires.
I mean, and it sounds kind of crazy. But if we look at
Whether, you know, if I think maybe they did it the opposite way, where if I didn't find someone guilty, right, I granted them freedom, I think is how they call it. So if I let the previous person go, right, I granted them freedom, I found them innocent. The next case I get that looks the exact same kind of as a pay, it's in the exact same location, exact same type of court case. I'm actually less likely, right, to let that person, the next person go. Right, and in fact, not even less likely, like the umpire effect was like what, 0.01 something? This is like 0.05. The probability that they find someone guilty the next time, if they previously found someone innocent or granted them freedom, goes down by what? 0.055%, right? So you're 5% less likely to be found innocent or 5% more likely to be found guilty. Right? So yeah, even though we find, you know, we can kind of estimate these things using sports data. And it will kind of suggest, like maybe in some of these other arenas, we see people falling victim when it comes to decision making. They always kind of try to balance it out, right? They think that, you know, this was a close one. Last time I went the other way, I'll go the opposite decision this time. And we see that even, you know, judges who have like a lot of experience, a lot of knowledge in this sector, they fall victim to this as well, right? Which obviously, you know, sending someone to jail, like that's a pretty, pretty bad thing for society. If it was the same court case, you found the previous person innocent, you should find them both innocent, right? But yeah, kind of an interesting kind of finding. So I wanted to kind of tackle this hot hand stuff today. I'll try to kind of, you got that fourth homework due today. I don't know if I'll get to look at that this weekend, but if I do, I'll probably try to give a quick look at a couple of the assignments, if I can't get through all of them. And probably do a little bit of review of what kind of maybe common errors I see. I'll also kind of try to build some models and bring in some papers for some of those topics and questions you guys had last class. Other than that, so a lot of you have kind of started reaching out and have given me questions and answer or stop by to work on your projects. So start thinking about those. If you need help with the data or anything like that, please let me know. Don't push it off. You know, we only got a couple more weeks left in the semester. Other than that, any questions from me before I let you guys get out of here? Yeah.
When are we presenting those?
So you don't have to present them, right? They're based, I mean, if you want to, I've had people, I think I have it written in the syllabus as an option. If you want to present it and film it, I can grade that, but more often, I mean, 99% of people generally just write a paper and turn it in. Okay. You don't have to present that at all. Yep. Okay.
Any other questions before you guys get out of here? All right, enjoy the last of what is this nice weather. I'll see you guys on Monday.